Hello everyone, this is Stas and welcome to my new series of tutorials that's called the Simple GLSL Tricks. It's aimed mostly toward the GLSL beginners and people who somewhat understand the syntax of GLSL but mostly don't use it because they're afraid of use it or not feels too good about using this. And in this series, I want to show you some simple tricks that you could easily do with maybe not couples, with 10 or 20 lines of code in GLSL, but that would be really hard to do without it just in TouchDesigner alone, or that would require a lot of CPU or GPU power if you do it without GLSL. And for the first example, we talk today is rotation in SOPs. Here is my setup. I have a torus. I send it to chop and then to top, and I instance it with cubes here, and I have connected it into another geo component with a wireframe font to have it without instances. And you could ask, why do we need GLSL here? Why couldn't we do it differently? So let me show you the easy way of doing this, straightforward way of doing this. Let's say we don't have a rotation here in geometry, and instead we have a rotation here in our transform SOP. And let's rotate it times seconds multiplied by 10. I don't know. And it seems that everything works fine. We have some FPS drop, but not so much. But that's mostly because our torus right now it's pretty simple. Let's increase the number of rows and columns. And now here we have a significant FPS drops down to 20. And this is still relatively simple geometry. It's a little above 100,000 points. And if you import some FBX file, it could easily have 1 million points, and transforming with SOPs would be very costly. Right now it's 27 milliseconds each frame of CPU time, and that's too much. And also the SOP conversion needs another 3 milliseconds, and this one another 1.5. So it's a good idea not to use transform. And with geometry itself, it's much better idea if you don't have any instances and you have just the geometry. It's much better idea to rotate it in geometry component itself, because it's very fast. It's it's super fast. And of course you could do the same here if you copy parameter, paste reference. Let me decrease the size of a box, and it still works. And in such a simple setup, you don't need to use any GLSL at all. You could rotate it in geometry. But sometimes after you convert your geometry into top, you want to do something with this top, and you want this SOP would be already rotated before you do something. Maybe you add some math, change some channels, add noise, or do whatever you need, and only after that you send into geometry. For example, here I have a setup with core noise, and this setup is comes from Bruno Imbrizi tutorial, Cool Noise, really recommend it to you. And here I have a geometry for banana, it's already converted to top, and I do a noise with it before sending instances to top. So I couldn't rotate it here. I need to rotate it before it comes into another GLSL component. So I made a GLSL component where I could set my rotationals. Okay. So I hope you understand why do you need sometimes to do it in GLSL, and let's do it. But first let me show you this setup, because maybe you're not familiar with converting SOPs into tops. Let's just insert a null because it's a good practice to use a null, and from null you couldn't straight away go to tops. You need first to convert it to chop, and then you could convert this chop into top. And here you need to set the data format as RGB, because you have 3 coordinates x, y, and z. And you don't need to crop long channels because the number of samples exceeded the texture resolution. And you fit text, instead you choose the fit texture to square. And now you have a square with all pixels. But actually it has a little bit more pixels than you need, because here we have 120,000 pixels, and here we have a little bit more, 62 pixels more. So here you could also set what to do with extra pixel values, because when you send it to instances, these extra pixels would be instanced as well. And right now it would be instanced in position 0, 0, 0. And maybe it's not what you want. Maybe you don't need this extra instance in the center of coordinates. I will show you later what to do with this. Just remember this setting for now. And before we begin with our GLSL, I want to show you a little bit different trick for converting SOPs, and for working with SOPs. Maybe it would be helpful for some of your situation. Suppose we have the constant chop or some other chop where you store all your parameters, and you have, for example, the parameter for number of rows in torus and for example 300, and you could reference it here and everything works fine. But if in the same chop you also have some dynamic parameters where you're using somewhere else, for example times seconds, it's do a bad service for us, because now, even though this parameter didn't used in our SOP, the chop still send our data every frame to this SOP, and every frame this SOP this node remains SOP again and again, and we still have a very low FPS. And you could try to solve it like this. You could try to select only number, and send only number here. But it's not working. It's not working still. So how to solve it? If you set a null, and by the way, you could just press Alt N and it will make a null for you, Alt plus N. And in null you have a parameter called the cook type. Let me reference from null. It cooks, but if we set the cook type not to automatic but to selective and set check values, it wouldn't send a new data until you change the channel here. So it sends one sample, it remade very fastly, and it's now fixed. And it didn't spend our FPS. I still have sometimes not 60, probably it's because I'm also recording my screen now. Okay, so let's start with GLSL. So we need to insert GLSL before we instance it. And since we work with rotation, let's put a vector called rotate, and let's just grab our values from here and send it here. So we want our instanced cubes have the same right now there is no cubes because we didn't do anything. So we need our instances with the same as our wireframe. And I didn't change anything except the rotation. So let me also check we have a 32-bit float, and maybe also set the nearest pixel. Okay, and start editing. First of all, we don't need, by default, it provides 2 lines for us, and we need this line because we want to grab our texture and output it. So here our torso. Let me arrange my screen something like this. Yeah, now it works. And let's call it text position. Let's call it text position. It contains the 4 values. And let me make another variable called just position, which is tpos RGB. And we will send here to output vec4 position, and alpha channel would be 1. So everything works. I'll explain a bit later why did I do it this way. And now we need to add a uniform called vec3, and I believe I called it urotate. Yeah, urotate. Rotate, and let's rotate it. What we need to do, the TouchDesigner provides for us the function called td_rotate on axis, and we need to multiply position by this value. So our position multiplied by td_rotate on axis, and we need to give a rotational angle. You rotate the same axis, and now it's rotating, but it's rotating too fast because this function requires the angle in radians, And we have a GLSL function for this. It's called radians, which convert our values from degrees into radians. And now our torus rotating the same speed. Let's add the y and z axis. y, z, but still something is wrong. And this is because we have a different coordinate system. We could have the left-handed coordinate system and the right-hand coordinate systems, and it will rotate in different direction. You could Google about it, but all you need to know is you could just put minus sign everywhere, and now everything works fine. So that's good. But what if we change the rotation order here from XYZ into XZY? It's not working again. And we could fix it. Let's fix it. First of all, yeah, it's just my personal preference. I like it. Put it this way. First of all, let's put all this rotation into another function, because our function will grow and grow and grow. And I call this function rotator, and it would be a vec3 function called rotator, and it requires vec3 position. It will do our rotations and return our position, return our new position. So here we need to redefine our position. Now our position, it's our function rotator position, and we should back what is wrong here. GLSL shader has compiled errors. Oh, I forgot to put the semicolon here. Okay, it works fine. So let's do something with the rotate order. This rotate order, it's always an integer. 0, 1, 2, and so on. So let's also grab this parameter and put it here in our fourth value. So paste reference. And let's check, let's choose the second one. So it's number 1 now. And since now we have 4 values, our uniform would be 4, vec4. And here we could set if-else function. And we could say if what? If you rotate value equals 0 equals 0, then we need to do this, because the 0 is when we have a XYZ rotation order. Boom, boom. Boom, boom. And let's copy paste it, and if we have a rotation order 1, it's X, Z, Y. So let's change it. X, Z, Y. Else if. So let's check how it works. and it seems working now. So I just made 2 strings, but of course you could use the else if another 3, 4, 5, 6 times and continue this function again and again, and it will rotate, it will check the rotation order. As for transform, translate and scale, you could easily use the math top for doing this. For example, if you want to scale, let me insert my top. If you want, for example, here we have a scale 2, and you could check and rearrange 2. Oops, it's not working somehow. Oh, it's because we need to insert our math before. Let me rewire it. I did something wrong. So here my math and then my GLSL, and now it worked. But you could also do this scaling and transforming and translating in the same code, and so you can have a function for translating and for scaling, and it's very simple, because translating is just moving some values in every axis, the scaling is multiplying the position on some values, so I leave it to you as an exercise. But I want to show you the pivot, because the pivot is a bit trickier. So what is a pivot point? Now our pivot point, the rotational center, is in the center of coordinates, but if we move it, for example, 1 point from here, then it will rotate around this new point. It's in our wireframe geometry. It will rotate in around the point 1, 0, 0. So what is a pivot? You could think about it as if you have a geometry, and then you translate geometry, this value, rotate it, and then translate geometry back. And this way, if you do it this way, the geometry itself wouldn't move, but it would look like it now rotating around different point. But probably it's much easier to just show it to you. I wouldn't do all new variables, I just show it like here, because it's just to make it super simple. We want to move our position. I'm not sure, should I add this position or let me check, and then if need I will change. 1, 1, 0, 0. 1, 0, 0, and then rotate, and after rotation I do it back. So it's these two lines would cancel out, but but now we have a rotation under different point, and now it's working. And if I check it this way, it doesn't work. So first you need to minus this position and then to plus. So this way, and of course for the better interface, you should make here another variable called upivot point, and here you need to paste this pivot, and so on and so on. But remember about this values, extra pixel values here. If I increase right now my instances, you could see that in the center of coordinates, rotated here, you could see it's a instance that doesn't belong to torus, but it's just in the center, in this 0, 0, 0. And we don't want this. What could we do? First of all, we could move it somewhere else. Now we don't have this point, but disadvantage is that if you have the viewer and say it home all, it never home into your torus, because you have also the point which is -99, -99, -99. So it's not a super good solution. And here the solution I came up with is to use another if-else statement. And here why we need this vec4 position, because if you think about it, you have XYZ values, you have XYZ values, so you wouldn't have the -99 on alpha channel. It's very weird. So you could just do something with pixels of these values. So if tpos equals vec4 -99, then do something. What could we do? I'm not sure that this is a super good solution, but it works. So let me show this. Let me stop. But this will work. You could take this deposition and divide it by 0. You should never divide anything by 0. It will produce an error. But by some oops. Something not working now. Why isn't working? Because it worked before. Let me just check what I did here. I believe it was the same. Very strange, very strange. Let me pause for a bit. I need to figure it out. Okay, I'm back. I understand what's going on. Here in our chop2 SOP, we have data format as RGB, and because we have a data format as RGB, the output format is also RGB. So when I said, when I checked that this is vec4 -99, it will never have this value because the alpha channel is empty. So what you could do instead, you could on this chop to swap change pixel format into RGBA, and now magic happens and you don't have these extra pixels. And if you choose the home all, it's in the home. It's not in the center because we have our pivot point changed, and you don't have now this these extra pixels. So probably that's it for today, and I encourage you to add to this GLSL translation and scaling functions, and with the same if-else statement you could also implement this transform order, and in the end you would have probably something like this my container. And so here I have transform order, rotate order, and so on, and everything should work. Let me check. If I change, I don't know, scale here, if I change rotation order, scaling order, uniform, and so on, it's still on the same position. It's still on the same position. But if you don't want to do it by yourself, you could be my Patreon supporter and I'll share this component over there. But actually it's super simple. It's just the one GLSL, and it's the same. It's translation, scaling, rotation, and a lot of if-else statement. Okay, probably that's it for today, and maybe, yeah, let me show you some super simple, because it looks very boring. Let me show what you could do next. You could, for example, insert noise, set it to 32 bits float, offset it back, maybe decrease the amplitude, and set it to simplex 4D, change it over time, maybe not so fast, and already you have quite an interesting result. Well, at least I think so. But if you send the results in SOAP into some curl noise I mentioned before, it would be much better and much interesting. Here is my curl noise. So I hope you like this series, and I will share more, probably someday, more simple GLSL tricks. I hope it was really simple. Let me count. It's just 40 lines of code and very useful result, and we have FPS around 60. Very nice. Okay, goodbye and see you next time.